So this one is a classic horizontal projectile problem. Now, you each have your own ways of solving the problems and keeping track of the information yourself. But if you're struggling, I would, as you read through the problem, circle or highlight all of the pertinent information. So here it says on one end of a spring is attached to a solid wall while the other end just reaches the edge of a horizontal tabletop, which is a distance h above the floor. So that's important, although it's pretty clear on the picture here. It's just pretty much comes from the diagram as well, but that won't always be the case. So it says a block is placed against the end of the spring and pushed towards the wall until the spring has been compressed a distance x. Now notice that distance is up here, and we've got another distance which you can start to anticipate will become a problem there. The block is released from the trajectory shown and strikes the floor a horizontal distance d, that's labeled right here, from the edge of the table. Air resistance is negligible, so we don't have to worry about that. And here's a big thing: determine expressions for the following quantities in terms of m, x, d, h, and g. So our answers can only contain those variables there. So let's look at the first part right here, where we solve for the time elapsed from the instant the block leaves the table to the instant it strikes the floor. We've done this before, so this should become pretty obvious. So we're going to use the third equation. I'm going to write it in vertical terms. So the vertical displacement is the initial y velocity times the time plus 1/2. I'm going to go ahead and call the vertical acceleration g times time squared. This will drop out because the initial y velocity for all horizontal projectile problems is 0. So this simplifies down to the vertical displacement is 1/2 times g times the time squared. And by now we should be getting used to this, that you solve it and we write 2 times the vertical displacement over g. The only thing you want to be careful of, and you could have done it from the beginning here, is that you want to substitute in here what the actual height is. So they're not calling it delta y, they're calling it little h right here. So it's 2h over g. On a free response, you have to show this. If this was somehow tied to a multiple choice, you could jump straight to this. But you have to show an equation, hopefully from the equation sheet, and show how you derive it there. So, next part here says what is the horizontal component of the velocity of the block just before it hits the floor. So by now we should be getting used to as well that we will also use the third equation horizontally. But this time, it is the plus 1/2 at squared that goes away. I'm not even going to write it this time because there is no x acceleration. So it simply simplifies down to this. Or you can even, in this case, you're allowed to just write the definition of something. So the definition of a velocity is the displacement over the time. So now we need to plug in for each of these variables. Now be careful on what we call the displacement. There'll be a tendency to come up here and just grab x, but that is not the displacement of the projectile. It is this distance from the edge of the tabletop to where it lands. So when we go to substitute in here, we want the distance is capital D, and the time is your time from the previous one. It is the time that you solve for right here. So we have to plug all of that down into the denominator. Now I know in math class they say you can't put a radical down in the denominator, but that's okay in this case. They won't take off if you leave it in that form there. So that is what the horizontal distance must be, or horizontal velocity to cover a distance d in that amount of time. So the next part here says, what is the acceleration of the block on the table? This will throw a lot of people off because they're so in horizontal projectile mindset that they keep trying to solve it like that. But this motion up here is simply a 1D motion problem. So what is going to happen is, let's write down our variables first. We know that our displacement, which we normally call delta x, is actually just called x up here. That's how far it moved. The spring is going to be released from rest, so we can say our initial x velocity is 0 meters per second. And here's a part that confuses some people. We actually know our final speed. Because our final speed in this part of the problem, part C, is actually right as it reaches the edge of the table. It's what we called our initial speed, our x speed in this case. So we know what speed it gets up to. It gets up to this value right here. So we can plug that in for our final speed. And we are looking for the acceleration. So what equation ties all four of these variables together at once? It is what we call the fifth one. The final velocity squared is equal to the initial velocity squared, but that's just 0, that drops out. Plus the term of 2 times the acceleration times the displacement. So now we can start to plug in here. We're solving for the acceleration. I'm going to go ahead and rearrange. The acceleration is equal to the final velocity squared divided by 2 times the displacement. So I'm going to plug in now. Here's our final velocity right here. I'm going to sort of write that as a separate fraction out here, and I'm going to square both parts. The numerator squared becomes d squared, and the whole part that's under the radical, that comes out of the radical because you square it. And all of that is being divided by, so I'm just going to write it in this case multiplied by 1 over. So all of this gets multiplied by that. Now you could have written a slightly different way. If you do your algebra here, you will see that you wind up with d squared on the top. The g will actually come back up here to the top part of that. And then on the bottom, we'll get 2 times 2 is 4, and we'll have an h and an x. So the acceleration of the block on the table must be that distance d squared times g divided by 4hx.